Hi guys, my name is Thuy. Today I'm gonna talk about my personal project for the final exam of deep learning. There's 5 parts in my presentation. The first one is introduction, project details, result and discussion, conclusions, and the last one is some reference that I used. So let's dive into my detail about our project. Yeah, as we all know that deep learning model with intense hidden layer provides us the very high accuracy and a large amount of hyperparameters. So it's understandable that you have to trade off between the accuracy and latency. If you want to have high accuracy, you have to make like intense hidden layer. It also increase the latencies. So yeah, it's trade-off. So like TinyML was born as the solution for that problem. About my detail of my project, first one, I have input that was recorded by OpenMV camera. And on training, it's just like data set that collected from the internet and then put it into a model. In particular, in this project is RascaNet. And then we will classify that there's Persian or non-Persian. Yes, before training or anything, we have to have data, right? This here is an MS COCO 2014 data set with the training and validation set, like about nearly 100,000 images for training and about more than 10,000 images for testing model. It is the models. Like in this part, I just reveal the RascaNet models that were provided by a paper that is very popular, like very famous in computer vision field. So this figure illustrates the architecture of RascaNet. The intuition of this method is you will split the original image to sub-images sequentially, and then with attention layers is used to make the feature extracted from CNN pay attention to the important features to prepare the hidden state of RNN as a query. We take the responsible for capturing the context of scanned region of image. So, and the last fully connected is like used to classify. Actually, the model is more complex than that. My project, I just do like this because originally the model is like implemented on PyTorch, and I rebuilt it on the TensorFlow. So I also make it like simpler to make myself easier to implement it and like control my code and for the training process. And that's about the general of RascaNet models. So because it's quite like complex and quite long, so because the limitation of time, so I'll just mention about something that I have trained and different from the original models. So I will not mention all the stuff. It's just like the difference between mine and the original model. The first difference is on the CNN block. In the original papers, they used multi-hat CNNs that, especially in particularly is the two hat CNN. Like we have the identical block, like I have showed on the screen, like convolution pooling 4 times, and they have a 2 block like this. And then finally they concatenate the 2-1. But in my project, I just use like normal CNN with this kind of layers, convolution, pooling, and then it's also the same for the next step with RNN attention and the last fully connected layers. But of course, it's also they have another differences. The first is loss function. Actually, they custom their own loss function without using any the traditional loss function like cross entropy or mean square error. To make myself easier, I just use the traditional loss function that have the provided library by Keras. It's like a binary cross entropy with the time-based decay learning rate. and the equation to like adjust the learning rate is shown on the screen. Another point that is different is they use early terminate to early stop. When you scan from the top to the bottom, maybe like you can stop in the middle because you have predict that there is portion or not. So you needn't to scan entire the image. So that's why they use early terminate. But actually, I don't use it. I just like scan from the bottom to the top, from the top to the bottom. I think the most important part here is like the result and discussion. You can see in the figure, I have a two graph to plot to show the loss function after. The first one is after each epochs. The second one is like the loss function with respective learning rate. Actually, our accuracy is just like 73%, and the testing accuracy is just like 72%. Actually, it's not high enough, right? Like you can see, the loss function of the train loss is quite stable, and it has quite good graph. It shows that our model is quite good on like converging from very high to quite low value, right? About the van loss is not stable, but actually it also have the good shape to show that the model is not bad, right? About the confusion matrix is showed on the screen, as you can see. It shows the model give the best accuracy for non-Persian class is about 76%. With the Persian class, the correct prediction percentage is 70%. So we can make conclusion that the model works better in the classification of non-Persian class. That's like with other evaluation method like precedent, recall, or F1 score. I think it's also show the same results as the confusion matrix, right? Because yeah, you can see clear that the result is the same with what we got from the previous, right? The model worked well on non-Persian, and like almost the evaluation method of class non-Persian is higher than the Persian class, except for precedent. It's like just smaller than about 1%. Let's observe some visualization to evaluate the model by your own eyes. The first situation is when the model is very confident with its prediction and is also correct. Yes, we can obviously observe that the right like some image that has people. However, in the left, the image is not easy to observe. Like you can see the train, right? But it also can predict correctly. So it proves that the result we got from the previous evaluation, like the non-Persian classification is better, is like reasonable, right? The next situation is when the model is confused between the two classes. It means that the distance of the predict probability is between the two is very small. Yeah, as you can observe in the figure on the screen, right? The probability between the two is just like one is 0.5, one is 0.4, and it's the same with the right image, right? So in this situation, the model is confused in predicting which class. In the right image is very clear that there is no portion in the image, but it doesn't not confident with its prediction. However, the prediction is also correct. The last situation is when it's very confident with its result, but actually it's not true. Like confident, but it's incorrect. So in the left image, like it's understandable because the person gets on with the background, especially it can confused with the two dots. Like, but in the right side, it's very clear in the middle. It's very clear that there's no person in the image, but it makes sure that there is. So that's why the model accuracy is not high enough. Like, it's understandable, reasonable. For the training and testing the model. About the real-time result, I have quantized the model, and after being quantized, the resulting file decreased from 559 kilobyte to 414 kilobyte, and accuracy is also increased about 0.5% to like 73.41% in validation set. Yeah, it's good, right? So that the following figure on the screen is some visualization of is predicted by the quantized model. Before I have some conclusions that about my project, I have previewed a RascaNet model and rebuilt it on TensorFlow. Then I apply to solve visual word problem. I also have evaluated the model on training test and validation test, and also quantized the model, and evaluate it also. But actually, it didn't reach the original paper accuracy, and I also can't run the model real time. So in the work in the future, I will check the model and improve the accuracy to like reach the result as they mentioned in the paper, and reduce the model to run real time on the microcontroller. Actually, I'm so refused that I haven't running at real time, because I have done everything until right now in this tab, but I haven't run real time. It's like also some revision, but like I have tried my best to do this project, so I like just like some reference that I use in this project, and you also can use this kind of reference, because I think it is quite useful in all the steps that I use in the project. So that's all for my presentation, and thank you for your attention from the first until right now, and thank you so much.